Hello, class. Today what we're going to do is the D&D stuff. What we have here is this amazing picture. Oh, yeah. Trollolololol. Anyway, so we have 3 Java files. And the neat thing about this program is all 3 of these Java files actually make one program. So if I right-click character, this is just an object. There's no void main. If I clicked archer, which is a subclass of character, there's no void main. Only in new characters there are void main. So I'm going to run this real quick to show you what happens. And what we have here is Dorcas's level 1 in his stats, Bandit's and Ugin's stats. And what it says here is Dorcas's damage is 10, Bandit's damage is 10. Bandit has appeared in this challenge Dorcas. You shall be attacking first. So you press enter to continue, and then next stats show up. So health, damage, and I press enter until someone dies. And it says both players have killed each other. Damage, and now Bandit has appeared and is challenged. So now I fight those 2 together, and then it says that Agne has won the fight. He leveled up. Hey man, check out what I can do with my fingers. I required my students to have a catchphrase for every time they won or lost. That's why that was there. But this is basically the toString method, the fight method, so on and so forth. The nice thing about this is, if we look into the code to this game is just this. 5 lines of code. That's it. This calls the battle function, which loops until done. This calls the battle function Dorcas versus Bandit, Agne versus Bandit, which is actually pretty cool. They have constructors to create. Now, basic constructors are just like, if I were to go int x equals 3, that's a constructor in quotes for a primitive variable type. For an object, which is character, I just have to do a new character. Now this new character has these things called parameters, which is a string and an int. So if I go into the character class, all the way up on the top, please notice that there is no public void main because it's just an object. There's all these variables, and then we have multiple constructors. We have 4 different constructors. If I pass in just a name, I just make it something with a name. If I pick a name and a level, I do name, level, then I ding up. If I pass in a name, level, and strength, I set the strength. If I do just the level, I do just the level. Now realize that if I just put in the level, I should have said name equals stupid, because it doesn't have a name. All the rest of this stuff is created down here. So I should have said start on each one of these, because start sets the default values right down here. Now realize that just because these are all the same names, the computer knows which ones to run based off of the parameters that are passed into the function. If I have 2 parameters, it's this one. However, please realize that, again, I can have this. If I just change the order of these parameters to be int and then string, string and then int, these are 2 different constructors, which are legal to do. Because the computer can tell the difference between an int and a string, so it can tell the difference between the 2 constructors, which you will have to make multiple constructors. Each constructor should do something different. It could be the same exact code, but the values will be different. Instead of S, I could put hello. If it didn't pass in this, it was just that. But that would break all the rest of the code if I did that, so I don't want to do that. The next thing you have is just a basic function, which just means run a whole bunch of code over and over and over and over again. Instead of writing it out for every single one, I'm going to make a function that sets the default. Now, what I should do is I should set this first, because then I set the level to be 0 and then set the level to be different. And then this takes care of all the parameters, and this can be ran for every function. It is extra code ran, so it will slow down the computer. However, it's efficient coding-wise, which is idly more important. It makes more sense to the user at a loss of speed, but the speed is so minor it doesn't matter, especially in this game. Then what we have here is the catchphrases. So he actually made a function to determine if vitality is the strongest, then do this. If endurance the strongest, if strength is, if dex, and if agility. That means based off of the random stats, each stat has its own quote, which is actually pretty cool. So it's like a random catchphrase for random characters. He has a way to get the current HP, which I don't like how this is written, because what this does, it recalculates the HP every time instead of having the live HP from stuff that's been lost. So this should be, instead of current, it should be called reset HP. That would make more sense there. And again, this is student's code. That's why we have the errors here, which is perfectly okay. This is actually a getter, is what they call it, because we're getting the value of HP from the variable HP up here under this object. This object is called, because we ran the character class, it's either called Bandit or Dorcas. Archer would be the Archer class, which has separate subfunctions. Now, please realize that Archer extends character, which means every code that's in the character function is also in the Archer function unless it is redeclared. So this calls the super function, which means call the character function for this one right here, string level, which is really cool because that means you can overload the functions, which this doesn't overload, it just calls the super class, or you can overload the ding function, which we're going to compare the ding to this ding right here. Please realize the dexterity is the only one that's different. So he changed the dexterity times 3 because it's an archer, so it should have faster dexterity. That's why ding is overridden, sorry. It's overridden in this because now we're calling the ding function the archer class instead of the character. The battle verse is actually where the beef of the coding is. This is the fighter. So this means wait for the user to press enter. We could be getting an input, but we don't care about it because we just want them to press enter so that the user can slowly see the input. It gets the damage of the objects. When we call this, we call it with a current object and we're passing in an object. This means the current object, which means Dorcas. The evil dot means the bandit, because the bandit is now evil. Because I pass it in as bandit, it becomes evil, because that's what it's declared in the function. So that means no matter what character type I pass in, it's going to be called evil, because it's the enemy. And this is apparently the good guy. So we output everything. We just get the name, because we want to say who they're fighting against. And we use this dot and evil dot to compare the two names. Then we press enter to continue. We wait for another input. And then we do while until someone dies. Which he did not this. He could have just done greater than or equal to 0 and not had the not. But that's up to him. Either way works. I'm going to leave his way because that was his way. Now realize he basically should have used a two-string method here, but he didn't. That's why he had to do it over and over again, which is okay. He could have made a function to output this to make it look nicer. So an output function for the battle rounds, instead of saying all this in there, it would have looked nicer. And then the damage is right here, which he calls a function to get the damage. So the damage is a variable, actually, which he should have made it a function because the damage could change depending on the person's HP. If it's a value, you can't change it. If it's a function, you can. And then down here he has if this won, if evil won, otherwise both players have killed each other. This is his error checking to make sure that the game can still work. Because the people do the damage at the same time, it could be a double knockout. He has a function to calculate the damage, what he should have used up here. But he probably called it somewhere in here. There you go, calc damage up here. So he calculated the damage and then did damage, which is probably better because then if this damage was based off of HP, evil's damage wouldn't be affected by the damage lost this round. So it was a instant damage to each other instead of damage and then damage. And realize that all that matters because running the function up here compared to doing a variable down here and doing the function down here instead. The difference between 10 lines means a completely different thing in the results of the battle. Then we have an avoid chance, which means a chance to dodge damage. If you lost, you actually lose a level. And if you won, you'll just level up, which doesn't increase. So he subtracted the level here because the ding method increases the level. So he just decreased the level. So he's still level 0, but they gain the stats from fighting. So it's like a Goku thing where even though he loses, he still gains strength. He has a getter. So this is a getter because I get the level. It returns the level as an integer. This is the return type. This is also another getter because I get the name as a string. So the function, so it would say evil.getName would actually become a string. Now this is called the parent class because the parent class is character. The child class or the subclass is the archer because archer extends character, which means take all the things from character and put it into the archer class. And then whatever I want to change about it, I change like this. So this would be no changes, except if you call archer instead of character, it just calls character. Because it extends character, so character would actually be put in here. Calc damage, I don't call the superclass calc damage. This damage is based off of dex, where in the character function, it's based off of strength and dex divided by 2. In the archer, it's strength divided by 2 and dex full. So they swapped what gets divided by 2. So that's pretty cool because now the archer damage is based off of dex instead of strength, which gives that class an advantage. They changed the way they level up because the archer should gain more dex in comparison. We get a dex bonus, which is really cool. And the battle function is done differently because there were supposed to be put in special abilities per class. So an archer can have a special ability. The warrior has a special stun ability. The archer could have a special trick shot, which damages the person's strength. So on and so forth, whatever you want to implement. And that's pretty much it. They didn't do the two-string method here, and we worked out. Please notice they're using minus equals because that's their programming style. You could write this out if you wanted to. They use /n instead. They're using system.out.println to stay away from graphics to base everything on the battle system itself. Please realize that some battle systems are really, really complex. It could be a whole bunch of code. So you don't see it. Yeah, here it is. So this code is actually quite short. Whereas the character class is a lot longer. That's because the archer class takes all the character class and I just want to make these few changes. The whole purpose of object-oriented programming is to be able to take someone else's character class and make it your own by just designing the small archer class. So the neat thing about this is, as long as you follow this template, you could have your character class extend someone else's character class and then have that be fought against someone else's program, so all you send them is your archer. If you follow programming standards, all you would have to turn in is your archer file, and that would work in someone else's test file, which is really cool. Yeah. So that means when you guys could, if you wanted to, you could turn in just your archer.java file into someone else's game and it actually work. But anyways, the neat thing about this is we're joining 3 different files into one file, and the nice thing about this is your test file, which is the new character, look how short this is. This is the game file that you run. So when I compile this, I'm literally only running this 5 lines of code. Because look, 1, 2, 3, 4, 5. This is all commented out, so I don't even need this. These 5 lines of code do all of this. All of this is made in 5 lines of code. I create 3 characters and have 2 fights in 5 lines of code. That's the power of object-oriented programming. Now, with that power comes great responsibility. What you have to realize is you need pseudocode. If you don't write pseudocode for this program, you will be stuck on this program forever. So write your pseudocode. Other than that, have a great day and don't forget to troll.